Welcome, everybody. This is the week 8 class meeting for the 6151 class. And this week we're going to be talking about project uncertainty, which includes risk, project risk, and complexity. I just wanted to maybe jump a little bit ahead here and look at week 9 for a second. Week 9 is next week. These assignments for this week aren't due until the Sunday of the next week. I'll go over the executive presentation. I'll make one of those myself, but then we'll talk about AI. I'm going to do a little presentation on AI and project management, and we'll talk about that since the PMI has actually added a whole appendix on that to PMBOK 8. I want to go ahead and talk about it now and in this course and get it integrated in. And we'll probably next week we'll do some, I was thinking we would use the Infinity program to do some of the end of course type things. I don't know exactly what that's going to be. I haven't thought it through yet, but that's where we are. But next week, they're actually due in 2 weeks, the 2 weeks from Sunday, tomorrow, the executive presentations, which are just essentially a annotated, voice narrated. If you want to do the cameo, have your face in there, that'd be great. I like those. And over all the different competencies, the course competencies. And you can click on this list here. And there's 13 of these course competencies. These presentations, those of you who've done them know what I'm talking about, but they're generally around 10 minutes, 10 to 15 minutes, somewhere in that range. And probably what we'll do next week is we'll go through each one of these. What I'm thinking is maybe we'll divide up into little small groups and take one of these competencies and then go out and do some little bit of research on it and come back and give your findings on it. And then that way you can use that as content to inform your presentation. Let me go back to week 8. Week 8 is evaluating project uncertainty and complexity. There's a bunch of nice readings here. And the forum activity, assessing and managing project uncertainty and complexity. All the things we've been talking about for planning, as I've mentioned before, they all happen when you're in a project and really working on it. You're going to be doing these things in slices and concurrently with each other. You'll have a planning session, say, to work on scope. Well, while you're there, you'll probably do some work on the risk involved. You'll do some work on stakeholder requirements. Be doing all, but the important thing is to know which one of these artifacts we need to update and what project documentation and what level of it we need to do. Even going all the way back to the decision to decide what framework you're going to use, what methodology, whether it's a predictive or adaptive or a hybrid. Complexity and the risk have informed that as well. It's when you're going through a course like this, you have to do them in a serial fashion because we're not together full time for enough time to work on this. Keep that in mind, that all these things run together. Let me start my little presentation here. Okay, you guys see that?
Yes.
Okay. Welcome to week 8. We're going to explore managing uncertainty, complexity, and risk for value delivery. Today, we're going to move from these foundational concepts that we've been talking about to a practical way that we can encounter uncertainty and risk in projects and how that happens. We'll talk about the relationship between uncertainty, risk, and complexity, and why uncertainty is unavoidable, and how risk is the measurable portion of uncertainty in the project, and how complexity amplifies both of those issues. And then we'll talk about the decision context and diagnostic models we have. There's a couple of frameworks we'll talk about for that. One of them is called Cynefin, and the other one's the Stacey matrix, to show why different project situations require different decision-making approaches. And then we'll look at those in context of how the PMBOK 8 and 7 reference those. We'll introduce the risk performance domain, which is a new way of thinking about risk and project management, and emphasize that risk is an ongoing capability that supports resilience and value delivery. And it's not a one-time thing like I'd mentioned earlier. And then we'll walk through the risk workflow, risk identification and risk analysis, and we'll look at quantitative and qualitative analysis and probability impact assessment and how risk informs decisions. And then after all that, we'll talk about risk response planning and contingency and mitigation planning and how we can use expected monetary value to support the contingency reserves decisions that we talked about. When we talked about budgeting, we talked about the contingency reserves. And then we'll conclude this by pulling everything together, summarizing things, talk about the takeaways. This is an overview here of uncertainty, risk, and complexity. Uncertainty is an umbrella. In other words, it covers risk, the measurable portion, risk is the measurable portion, and then complexity amplifies both of those. In other words, complexity just adds to this. And PMBOK 7 and PMBOK 8 focus on the context, and it helps to treat these things as connected, not as separate topics. That's why we just talk about uncertainty. Uncertainty is defined as it's a broad condition of not knowing future states that could affect project objectives. And risk is the portion of uncertainty that we can describe well enough to evaluate. In that we have threats and opportunities. And there's a probability and an impact component to each one of those that we need to think about. And then complexity is not just more risk, but it increases the number of interacting elements and dependencies, stakeholders, and interfaces and feedback loops. And it makes outcomes harder to predict, increases the amount of uncertainty and difficulty we have when it comes to managing risk. And this explains why predictive approaches work in stable, low complexity settings, and while adaptive or hybrid approaches are needed when more complexity or when uncertainty is high. This positions how that works in planning. Uncertainty and understanding project uncertainty. Again, project uncertainty arises from incomplete knowledge about future conditions that affect project objectives. It's a lack of complete information or understanding about events, issues, or solutions that are associated with a project. And it makes it difficult to anticipate outcomes, to make confident decisions, and plan with precision. As a result, uncertainty increases the exposure to risk affecting cost, schedule, and performance objectives. And it can originate from multiple sources, including conflicting stakeholder perspectives, changing or incomplete requirements, technological challenges, external disruptions beyond the organization's control. And for example, limited knowledge of customer needs early in the project or unexpected events during execution can significantly amplify uncertainty. And as uncertainty increases, project teams often rely more on assumptions rather than on verified facts. And when we do that, requires more frequent assessment of decisions, more leverage to innovative, iterative planning, and adaptive approaches that allow the project to evolve as the information becomes available. Effective stakeholder engagement, risk management, and communications become critical for preventing uncertainty from escalating into unmanageable risk. And a big part of what we're trying to do is keep the level of uncertainty. We know it's going to happen, but to keep it to a level that it's not becoming a risk to the project. It enables us to make informed decisions about the project lifecycle, how much planning we need to do, how much governance we need to apply, and to make sure that the project approaches remain aligned with how the project evolves and needs and the value delivery goals of the project. And I mentioned this, I think, last week, the cone of uncertainty. Uncertainty is highest early and narrows as information increases and decisions are validated. The cone of uncertainty is a practical concept or model that helps us to explain why early estimates are inherently less reliable. Teams simply don't know enough yet to make a reliable estimate. However, as work progresses and the uncertainty narrows because assumptions get tested and validated, requirements become more clear, and the technical feasibility of what we're doing gets validated. And this is why in project management, we emphasize the modern thinking is we emphasize learning, feedback, and tailoring. The project should be structured to reduce uncertainty intentionally through different validation cycles, stakeholder engagement, and iterative planning. The problem is if we treat early estimates as fixed commitments, we can have unavoidable situation. We've got rework and cost and schedule variance, and we cause tension with our governance setup. The thing is, we can, if we commit to it too early, then we've got ourselves in a situation where as the project evolves and things change, we could find out that we didn't account for something that we didn't know at the time as we learn more. That's why the emphasis is on learning, is because we can always do this. And then even in a predictive project, the linear approach, you can still look at this uncertainty factor and say, well, this is real uncertain. We need to revisit this issue and set up planning gates, if you will, to manage the things as we move through the project. And in governance, we're going to talk about governance here in the presence of uncertainty. So effective governance recognizes the cone of uncertainty and tightens commitments as knowledge increases. And in PMBOK 7 and PMBOK 8, they both emphasize that governance should respond to uncertainty rather than ignore it. And that's what I was just talking about. Early in the project, uncertainty is high and information is limited. So our governance should focus in that direction. It's alignment and learning, not too rigid commitments to cost and schedule or scope at this point. And as uncertainty narrows through discovery, through prototyping, through stakeholder feedback, through incremental delivery, through whatever mechanisms we set up to plan, and we want to progressively tighten down to where we feel we can make a commitment. Back out here, we're talking rough order of magnitude. We could be 100% or 150% off based on here. But as we get closer, we're getting more into what we could call a definitive estimate number in reduced uncertainty. Projects fail usually when stakeholders expect early precision over in this part of the project. And a lot of times as project managers, we're pressured into making these early commitments because stakeholders want this commitment early. They can feel like they've got a handle on what's going on and they can move on to something else. Then we put ourselves in a situation where we're basically set ourselves up to fail, and we don't want to do that. In effective governance, we align these decision rights and approval thresholds. Decision rights in terms of team has the ability to make decisions, or the key stakeholders. And the approval thresholds, what range of looking at and what confidence levels. And then performance expectations with the project's evolving level of knowledge. It could be that even matter of fact, most of the times when we start off the project, we think we've done a real good job of working through the requirements, eliminating a lot of uncertainty, and maybe there's a few risks left that we need to monitor. But things change. I think there's a famous, I can't remember which, I think Mike Tyson said something about plans are great until somebody punches you in the face, something like that. Things change over time. Nothing's like actually executing a project to know what's going on. This cone of uncertainty concept, if we keep it in mind, it helps us to better design our governance structures, helps us better select life cycle we're working on, and gives us ability to make more realistic forecasting, which in turn improves the value delivery in the project. And this graph here is conceptually how complexity might reshape this cone of uncertainty. You can see it's gotten all distorted. Higher project complexity slows and distorts and reshapes the narrowing of uncertainty. The traditional cone of uncertainty assumes that as time passes, knowledge steadily increases and uncertainty narrows in a predictable way. But however, the PMI emphasizes that this assumption holds primarily on low complexity environments. In complex environments, those with lots of dependencies, dynamic stakeholder relationships, evolving technologies, external pressures, uncertainty doesn't decrease smoothly. New information can introduce additional uncertainty. It can invalidate prior assumptions or trigger cascading effects across the project system if you view the project as a system, and as we do now. And as a result, this cone of uncertainty may narrow more slowly, may plateau, it might even widen a little bit and get bulky, lumpy. And this is why complexity fundamentally reshapes this cone of uncertainty rather than just extending it. That's the thinking that, well, the more complex, the longer the project, but it's dynamic. And as project managers, we should expect nonlinear this nonlinear concept to learning and design and governance and planning and decision making. And the processes that accommodate emergence rather than assuming steady convergence. There's a little bit of difference here. We can understand things to a certain point, but as the project system interacts with itself, there's going to be things that we hadn't think about that emerge, those unknown unknowns that I mentioned last week. And we'll cover that concept again too later on. But understanding this dynamic relationship with uncertainty and time and the cone of uncertainty is why usually projects that are very complex incorporate more intentional feedback and have more of an iterative or a revelation type of project. Even in the predictive models, we can adopt a rolling wave planning or a continuous elaboration type of functionality early on and carry that on throughout the project. Again, this is just another depiction of complexity and uncertainty in the project. And we're moving in from uncertainty now into complexity, which amplifies uncertainty. And project complexity arises from the number, diversity, and interdependence of the different project elements. This is the degree to which a project consists of multiple interconnected elements that interact in dynamic and unpredictable ways. You can see on the slide here all these different stakeholders and the different organizations here, and all these things are interconnected. And this is one big system, the project team and task and system and regulators. So there's all these elements that we have to think about. This complexity is not simply driven by the size of the project, but by the number of interdependencies between all the components, like task and technology and stakeholders and governance. It's complexities associated with systems thinking. When elements interact and outcomes can't always be understood by analyzing the components in isolation, we have to think of it as a system where small changes in one part of the system can create disproportionate effects elsewhere. And this is what we call emergence. It's a phenomenon that happens when we have interdependent things. And we talk about AI has emerging lately, and AI has emerged from this interdependence on all the math that goes into these models, the machine learning and models. And we really even don't really understand how it happens. We have an idea what's going on, but one of the scary parts of all this AI stuff is the underlying emergence of the artificial intelligence itself. We don't really yet quite understand exactly how that happens. There's some theories out there, but we still don't quite understand. It's the same thing happens in projects with all these interdependencies. All of a sudden, issues, risk, uncertainty, things we hadn't considered, opportunities emerge, threats. It's not inherently negative. Complex projects can deliver significant value, but they require different leadership behaviors and planning approaches in governance structures than low complexity projects. The same governance structure, same oversight, if you will, for a low complex project, if you try to apply that to a complex project, you're going to constrict that and distort the value that it delivers. And it could be detrimental in that way. You have to learn to adapt the governance cycle as well to the complexity of the project. So recognize how much complexity we have allows us to avoid what we call false precision. And we can have design approaches that support learning, adaptability, and alignment that help us uncover what's going on and establish that precision. Complex doesn't necessarily mean complicated. Complexity it's about interaction, not difficulty. And you can manage complexity through structure and leadership, not through prediction. If you try to predict too early in complex, you can create problems for yourself. And all of this is to set up a conceptual framework for when we get into looking at how much uncertainty that we can identify and analyze as risk. Complexity amplifies that, it increases maybe the need or the frequency that we need to look at things. Different types of complexity. Complexity arises from structural and dynamic and social political sources. It's multidimensional, project complexity is. Structural complexity is the number of components. It reflects the number of components and tasks and interdependencies within the project itself. And as these increase, the coordination and management of the project becomes more difficult. And failure in one area can cascade into another area. Dynamic complexity arises from change over time. Even when we have structures that are known, our project structure is known, evolving requirements and emerging risk, learning, feedback loops have an unpredictable impact on the behavior of the project. And then the social political complexity comes from the differences among all the different stakeholders in terms of priority, their influence, the culture of the organization, incentives, and the power dynamics within the project and the organization. This form of complexity is usually the least visible, but it can have maybe the greatest impact on outcomes. And I don't know how many of you worked on projects like this where you think it's just going right along and you have one influential stakeholder or somebody that has a certain social political power within the organization can derail what's going on. And you have to factor that into the complexity formula. These forms of complexity rarely or maybe never occur in isolation. Instead, they interact and reinforce one another and shape how this uncertainty and complexity behaves and how we need to adapt our management style to manage the project. Different contexts require different ways of understanding problems. And the next few slides here, we're going to introduce two complementary sense-making models to help us make sense of this complexity and uncertainty. One's called the Cynefin framework, and the other is called the Stacey matrix. And they help us diagnose the project's uncertainty and complexity. In understanding this context, it's important for understanding project risk. These tools need to be applied as we're choosing our governance and planning depth and leadership behaviors or life cycle approaches. So we can apply these early on in our project thinking. And we'll talk about the Cynefin network. Cynefin, making sense of complexity, is the idea with I think they even call it chaos framework. And Cynefin frameworks helps project managers and leaders recognize the context of the project and respond appropriately. And it was developed by David Snowden, a fellow named David Snowden, in 1999. And it's a decision-making model designed to help us understand how to respond appropriately to different types of situations, particularly situations that involve uncertainty and complexity. Instead of prescribing a single method, Cynefin helps us to diagnose context and adapt this decision-making behavior accordingly. And the framework categorizes these situations into 4 domains. And each domain has a different cause and effect characteristics in leadership responses. You can see in the 4 quadrants here. And over here in the clear, or what's often called obvious domain, the cause and effect relationships are clear, predictable, and repeatable. And the correct response here is to sense, in other words, to identify, categorize, and respond using established best practices. These situations like this are stable, they're routine, but they require vigilance to avoid complacency. So those are usually the things that we take for granted on the project. And they can, if we don't keep track of them and pay proper attention to them, they can emerge into risks that we have to deal with. The complicated domain, the cause and effect relationship exists, but they're not immediately apparent. There may be multiple viable solutions available. And what is required here usually this is where that expert judgment comes in that we talk about. We need to analyze instead of categorize like before and respond, relying usually on specialist or technical expertise to determine the best course of action. The complex domain is where a lot of our projects exist these days. And here the cause and effect relationships are not predictable in advance due to interdependencies, competing factors, and this emergence phenomenon that I talked about. We can't fully define the output up front. Solutions can't be. Instead, we use a probe, sense, and respond approach, experimenting, learning from feedback, and adapting over time. And this aligns closely with the modern emphasis on learning, adaptability, and value delivery. We learn more as this creating this learning system that we're talking about. And in the chaotic domain, there's no real discernible cause and effect relationship that exists. These systems usually involve crisis or immediate action is required to stabilize the environment. We act first, then we have to sense and respond once order's restored. Planning and analysis, in this case, come after stabilization. We commonly call this putting out fires, and you don't really want to be in this chaotic domain. This is where really the project's gotten out of control. We can use this Cynefin network by assessing the situation and then categorizing it into what domain are we operating in, and then applying this logic. This gives us a framework, it gives us guidelines on how to make decisions, decision logic. This framework is really valuable for helping us manage ambiguity and improving our situational awareness and avoiding inappropriate responses and apply the best practices to complex problems. This is one tool we can use. In application, different project situations require different decision approaches. We're going to go through some examples here, even on the same projects. We can see how the Cynefin works in practice here. Consider a large global software development project. Within a single project, we could have multiple Cynefin domains present all at the same time. Some activities, like software configuration, standard software configuration, fall into that simple domain. They're routine tasks, and they're well documented and they're repeatable. The appropriate approach here would be to apply established best practices, like maybe we have a standard operating procedure or a flow chart we follow, a method of operations that we follow, with light oversight, and we do this to ensure consistency and quality. But we have other activities, maybe like custom integrations that are requested by specific departments. These fall into the complicated. And the cause and effect relationship exists, but it's not immediately obvious because we have that customization. And they require technical analysis, and expert input might be expert stakeholder input to identify optimal solutions. And we want to meet both the functional and operational requirements in here. And then during deployment, we may need user feedback that could reveal unexpected issues, stability issues. And these challenges represent this complex domain where the causes are unclear and they're usually interdependent. And in this context, the correct response is not actually detailed by upfront planning because it's a defect that we found, but through experimentation. We have to try to repeat the issue that we're having. And we use this probe and sense approach. We try this, and does it work? And what's actually going on? And we run pilots, we connect data, we adapt the solutions iteratively through this testing. And through that, we get a better understanding of the problem, and we can apply solution to the problem. And then if we have some critical system failure, like mid-deployment, the situation shifts to a chaotic domain. Maybe we have the system crash or something like that. We might have immediate action to restore service and stabilize operations. Then we need to act first and activate backup systems, and then analyze root causes once stability is achieved. I actually had a situation like this happen I worked at a company where we managed the shopping cart for the Capital One rewards program. And we had all these servers. As the system would run, we had a memory leak as a problem, but what we found, but what the cause of the symptoms were is that it would run and eventually the system would just crash. And then we'd have to bring it back on and try to and we kept trying this over and over. We eventually found that they had a memory leak. What that means is as the software runs, it just allocates memory and doesn't release it back to use. And eventually you run out of enough resources on the server to run the software. We had to do root cause analysis. It took us a long time. It took us a couple of weeks to figure it out. In the meantime, we had to throttle the system up and down to release the memory. And it was caused by one of the software developers uploaded an older version of some of the stuff he was working on. We had a problem with our configuration management system when it comes to building and deploying the software. That's a governance issue. We had to go back and rethink that and come up with a new process for when to make sure that things were validated. But it was a put out the fires. It was very highly stressful situations. But we can analyze the Cynefin to figure out where we are and then look at, well, okay, how do we address this? And instead of matching a one-size-fits-all decision-making approach, we can reduce our reliance on false precision, and we can enable progress by understanding where we are in this complex uncertainty environment. The next one here, the second one, is the Stacey matrix. And as certainty and agreement decrease, projects move from predictable to complex and require adaptive decision making. This is what happens once we're in progress. And it was developed by Ralph Stacey around 1996. And it's a decision making and strategic planning tool used to understand levels of complexity, uncertainty in projects and in organizational contexts. Both of these situations can be applied to organizational management or design, as well as project management. Specifically for projects, it helps teams determine which management and delivery approaches are appropriate for the situation that you face. And the model explains why agreement and certainty matter just as much as technical difficulty, the dynamics of that decision-making in agreement and uncertainty. It's organized around two axes. It's the same as the others. It's a 2x2 matrix, and it represents certainty of technology or methods. In other words, it talks about how well we understand how the work can be done. High certainty means that we have proven tools, we have stable processes, we have known pathways. Low certainty indicates unfamiliar technology, evolving methods, and unclear situations. The second axis represents the level of agreement. This one here, the y-axis, a level of agreements on goals on the what of we're doing. The high agreement means that stakeholders share common understanding of required outcomes. Low agreement reflects competing priorities and conflicting expectations and unresolved trade-offs. When both certainty and agreement are high, the work falls into the simple zone. And in this context, the cause and effect relationships are predictable, and standard practices are linear, or predictive approaches are effective and efficient. So you can see a correlation here with the Cynefin framework. They're the same thing, just a little different view. And as situations become more involved, but they're still relatively stable, they can move to the complicated zone. And here, agreement and certainty still exist, but expert analysis and additional resources are needed to determine the best solution. Now we've got alternatives that we can do. Traditional project management techniques continue to work well when they're supported by specialist expertise. And then when either certainty or agreement break down, the situation enters this complex zone. We may have unclear goals, or the goals may be contested, and methods may be uncertain or contested. And in this area or in this space, outcomes emerge through interaction rather than through prediction. Again, we're in that complex area, chaos area. And adaptive approaches such as iterative planning and experimentation and frequent feedback are more effective here. At the extreme, when both the how and the what are highly uncertain, the situation becomes chaotic. And this is sometimes referred to as the anarchy zone. In these cases, immediate action is required to stabilize the environment. Only after stability is restored can we begin to learn and analyze and move forward. And the Stacey matrix reinforces the principle that there's no single best approach. Predictive methods are appropriate in simple and complex, while agile, hybrid, or exploratory strategies are better suited to complex or chaotic situations. So when we get into risk identification and risk planning, we're going to need to understand which risks are straightforward and which risks are more complex. And by diagnosing the context of the risk, we can approach different risks in different ways. In other words, we can tailor our risk decision, our risk approach, our risk acceptance strategy, whether it's mitigation or acceptance. We can adjust those approaches based on what we know about the risk. We can apply the Stacey matrix the same way. Different parts of the same project can fall into different zones, like with the Cynefin. And to illustrate this, the Stacey matrix in practice, we can, again, we'll look at a multi-million-dollar healthcare project example here. This involves research and development, manufacturing, and marketing, while also operating under strict regulatory constraints. And throughout the project, uncertainty exists around technology and stakeholder requirements and external conditions. Some aspects of the projects will fall into the simple zone. For example, manufacturing our medical device using standard components and established assembly line processes that are predictable and well understood. Here, the technology and requirements are clear in making predictive or linear methods effective. Here we can follow optimized workflows with some degree of confidence. And then other aspects of the project will fall into this complicated zone, like the design of the user interface. While governed by agreed upon ergonomic compliance methods or requirements, it still requires UI expertise. And usability experts or human-machine interaction tools and data analysis are needed to identify optimal interface. And here we have expert-driven analysis and structured prototyping that work best. It's the best approach. And maybe the project enters a complex zone when unexpected device behavior appears during testing. For instance, the device may perform inconsistently under different environmental conditions. The cause and effect relationships here are unclear because of this difference. Existing methods may no longer apply directly. In this situation, an emergent approach is required where we run additional tests and we gather feedback and we iteratively refine software algorithms using more adaptive techniques. And then now midway through the project, an announcement of a new government regulation creates a chaotic situation. A project like this, where we have a long life cycle, the regulatory environment can change. And this creates chaos in both requirements and what the device now both need to comply with new requirements. Now we have new methods and how now we need to understand how we're going to achieve compliance. All this becomes unclear and we have immediate action to stabilize. We may have to pause development work and reform some regulatory investigation and focus on crisis management. How do we adopt these new regulations until that's restored? Then we can maybe have to replan this. By understanding all these different challenges on the Stacey matrix, we can avoid treating all problems the same way. Again, it's the same concepts as with the Cynefin model. Instead, our approach to risk and approach to planning in general can be matched to the level of uncertainty that and agreement that are present within the project. And that helps us to stabilize the decision-making and progress despite this uncertain and complex environment that we find ourselves in. Using these models together can help us diagnose the project context. Cynefin and Stacey provide similar and complementary lenses for diagnosing project context and guiding decisions. Cynefin tells us how to act. Stacey explains why it's hard. The Cynefin and Stacey metrics are often thought of as separate items, but together they provide a powerful diagnostic approach for project teams when we're navigating through uncertainty and complexity. The Cynefin framework focuses on a situational context. It helps us understand the nature of the environment we're operating in and whether cause and effect relationships are clear and discoverable through analysis. And Cynefin primarily guides decision behavior, such as when to apply best practices, when to rely on experts, when experimentation and learning are appropriate, and when to act immediately to stabilize the situation. The Stacey matrix, in contrast, focuses on why the situation becomes complex. It examines the degree of certainty in technology or methods and the level of agreement on requirements or goals among stakeholders. It helps us to explain how complexity emerges when certainty and agreement erode, even within technically sophisticated projects. We can use these models together to diagnose the context from different angles, from two different angles. We can diagnose it from how we should respond in a particular moment. And then we can look at it as to what conditions are driving the situation. And this insight helps to support better decisions about planning, how much depth we need to do to planning, how much stakeholder engagement is involved, and life cycle selection. Rather than asking which framework we should use, we should ask, what does the context require now? They help us answer that question. We can use these things to tailor our management decisions. We've talked a lot about tailoring as a key concept in modern project management. In the PMBOK 8, there's a whole chapter based on it. And I believe in PMBOK 7 there was too. But effective tailoring emerges from understanding context, uncertainty, and agreement. We talked about tailoring is essential for figuring out which methodology that we're applying, whether it's a predictive, adaptive, or a hybrid. We can also look at the same concept for tailoring our risk responses to understand what's effective. We shouldn't drive this just out of habit or by preference. It needs to be driven by the context that we find ourselves in. And I've been talking about this ever since we started, that the project itself should be adjusted or adapted to the context of the environment that we're in or the system that we're in. And then we should adapt our approaches that way. Even in predictive environments, all processes don't apply all the time in the same way in adaptive and hybrid. And we have to look at risk the same way. And that's one of the reasons we talk about uncertainty at the end of the course here, because it's difficult to position that in the beginning as an overarching strategy. So Cynefin helps us understand the nature of the situation. We've been talking about whether practices, expert analysis are required. And when both certainty and agreement are high, we can favor more predictive approaches and when we're talking about risk, we can understand the probability and impact of the risk. And by combining the strategy, we can get a richer understanding of what we're in, and it lends itself to a more dynamic leadership situation. Now we transition from context to complexity and project risk. And understanding context and complexity provides the foundation for effective risk management. That's where we've been going. And up to this point, I focused on understanding the project context and how uncertainty and complexity behave and how they shape decision-making and how project teams can tailor approaches accordingly. And this is a essential foundation that risk does not exist independently of context. Project risk emerge from uncertainty, interdependencies, stakeholder dynamics, and external conditions. And without understanding these drivers, risk management becomes a mechanical exercise, focuses basically just on the risk registers and checklists rather than a meaningful decision support. And I've seen this time and time again in projects where they have this big emphasis in planning to we're going to identify the risk, and it winds up being the same 10 or 15 risks for every single project. And they never really look at, well, what are we trying to accomplish and what are the threats and opportunities that are involved with the context of what we're trying to do. And they don't really do a really deep risk analysis or risk identification analysis process. And then what happens, things happen and they wind up in that chaos or that firefighting situation. And the project never seems to get out of the firefighting mode. And it becomes a fire drill all the way up to the end of the project. And what happens in that situation, my experience has been, is that morale suffers. Nobody likes to be associated with something that they know is going to fail or that has a high probability of failure. People like to be associated with success. And success is something that is created, not predicted throughout the project. And you wind up in a situation where, again, I'm brought in as a consultant to do what's this project. All we're doing is putting out fires. We can't get any planning done. Everything is happening chaotically. Come in and help us get our hands on this project. Well, you have to go back to, okay, did you do your baselines all right? And what estimating did you do? What risk analysis? And it's all integrated into this process. And we need to emphasize that risk management is not about eliminating uncertainty, as teams try to do sometimes, but it's about informed decision makings in the presence of uncertainty as we go through the project. Context diagnosis models like Cynefin and Stacey help us anticipate what kinds of risks are likely to emerge and how the responses should be designed. And the transition here sets the stage for looking at risk management not as a standalone process where we're doing checklists and we're basically doing busy work, into an aligned, integrated capability that supports value delivery in these uncertain and dynamic environments that we found ourselves in. The concept here is that risk, it's a function of uncertainty and complexity, and it emerges from uncertainty and it's amplified, as mentioned earlier, by complexity. In modern project management, we no longer treat risk as an isolated process artifact. Instead, it's understood as a function of uncertainty and complexity within our project environment. Uncertainty represents incomplete knowledge about future conditions, events, or outcomes. On its own, uncertainty creates a range of possible futures, and risk emerges when those uncertainties have the potential to affect our project objectives, either in a positive or a negative fashion. And complexity amplifies this effect. Interdependencies among tasks, technologies, stakeholders, and external systems increase the number of interactions and feedback loops. As complexity increases, small uncertainties can cascade into significant impacts, making risk harder to predict and manage using project management linear approaches. This perspective explains why risk management techniques that work well in low complexity environments often struggle in complex projects. It also reinforces why adaptive planning or frequent reassessment and strong stakeholder engagement are important in managing risk effectively. In understanding risk as a function of uncertainty and complexity shifts the focus of risk management away from prediction towards continuous awareness, learning, and informed decision-making in support of value delivery. Risk isn't the problem. Unmanaged uncertainty in complex system is. Complexity has the same phenomenon that communications has in a project. If you can think about as the number of stakeholders increases, the importance of effective communication grows exponentially. The number of communication channels, it grows exponentially. The more interdependencies you have within a project, the more complexity grows, and it tends to have an exponential effect. That's where this amplification comes in. It's not a straight line complexity. We have more dependencies, more complexity grows. It's a curved line, and it compounds the more interdependencies that we have. We're looking at defining risk here in the way that we look at it in modern project management. Risk isn't, as we mentioned earlier, risk in an uncertain condition that can affect project objectives positively or negatively. This slide here is showing how risk and opportunities, threats and opportunities can come throughout the project, can be at essentially any time. It's the technical definition of project risk is that it is an uncertain event or condition that, if it occurs, has a positive or negative effect on one or more project objectives. These objectives may include scope, schedule, cost, quality, performance, or value delivery. There's two important shifts here that we're seeing in modern project management. First is that risk is explicitly tied to uncertainty. Risk exists because future conditions are not fully known. And second, risk includes both threats and opportunities. And it's not just about avoiding losses, but it's also about recognizing and enabling favorable outcomes. Risk is therefore not something separate from project work. It emerges from decisions, assumptions, interdependencies, and stakeholder dynamics and external conditions. Effective risk management focuses on understanding how uncertainty may affect objectives and making informed choices to enhance value. And this definition of risk reinforces why risk management needs to be continuous throughout the project and integrated with planning, execution, and governance, and not treated as a one-time activity or an administrative requirement. Like I had mentioned before, when I go in sometimes and they do this all at once and they never do any more risk evaluation. The thing is that uncertainty still exists, and if we're not trying to understand how much of that uncertainty is definable, how much of it is not definable, then we're going to find ourselves in a chaotic situation because we'll have more undefinable uncertainty and complexity than what we understand. This is an important shift here. And also the focus on opportunities. It's not just about opportunities like how much more finance, it's about opportunities improvement of our processes. One of the things that we've adapted in modern thinking is that we do frequent retrospectives on what's occurred so that we can improve and build better best practices, build better, more impactful processes in how we approach work to learn and improve that comes out of that. The focus on opportunities is just as equally as important as focus on the threats. We go through this. There's risk or uncertainty. We're talking about threats, opportunities, and issues. The risks are uncertain and can be negative. We call those threats, or positive. We call those opportunities. And issues are related, and we'll talk about them here because they're really current problems that require immediate management. Issues fall into that chaos category or critical category that we saw in the two models. And as we've emphasized before, risks are defined by uncertainty, and risks may occur in the future and could affect project outcomes. And risk can move in two directions. Threats represent uncertain events that, if they occur, negatively impact project objectives such as schedule, cost, or quality or performance. And opportunities are uncertain events that, if they occur, create a positive outcomes such as a cost savings or a schedule acceleration, or maybe we can find a way to increase the value that we're going to deliver. And in contrast, an issue is a current problem or condition that has already occurred or is actively happening, and they're no longer uncertain, and therefore they require an immediate action or immediate management, and not probability analysis or contingency planning. An issue has something, it's a problem we have to resolve. And on the slide here, they've got an issue is that we have a critical bug that's causing the software to crash, like before. We've got to fix that. And we have to probe and try to understand and analyze it. An opportunity risk is it's uncertain, it has a positive outcome. And the example here is a new technology could speed up our development process. And then the threat risk is have a negative or harm on their project objectives. An example here is a key supplier could delay delivery of critical materials. So the way we distinguish between all these is that if it might happen, it's a risk. If it's happening, it's an issue. If it could help, it's an opportunity. And if it could hurt, it's a threat. Understanding this distinction is critical because risks require planning and monitoring, and while issues require action, escalation, and recovery. Still on the constraints, risk, and issues, that the risk constraints define boundaries of the project, and risk arise from uncertainty within those boundaries. And as we mentioned, modern project management defines risk as the level of the part of uncertainty that we can define. And it's an uncertain event, if it occurs, has a positive negative. I'm going to repeat that because we have to get it through. This point is critical because without uncertainty, there is no risk, as we mentioned with the issues. An event that is certain to occur in the future is not considered a risk. And if there's no uncertainty about whether an event's going to happen, it's treated as a fact or as a constraint, which is another thing to think about. Constraints are not risk. Constraints, how a project is planned and executed, but they're not managed through the risk response process because the probability is not a factor. Like a good example might be that if we need a building permit and where approval is scheduled for a specific date, and there's no uncertainty around it, that we're just going to get the approval. But if there's some uncertainty, maybe we're not going to pass the inspection, then we have a problem there, an issue, a risk that we might do. A project constraint is something that it could affect our timeline, could affect our script, and we need to manage or plan to project constraints. And similar to an issue, but the thing is, constraints exist outside of the project, or they're inherent in the project work itself. And we need to plan activities around like known dates and sequence of work constraints and sequence of work accordingly. If there's an uncertainty about whether, like in the case of the permit, then maybe there's a potential regulatory delay or something like that, then there's a risk to fulfilling that constraint. And we need to develop a contingency plan by monitoring leading indicators or engage stakeholders to reduce the likelihood of that delay. We need to get into the risk mode with that. And the distinction here between constraints and issues and risk, all this matters because it determines how we need to respond. Certain future events are recognized through planning and sequencing and dependency management, where uncertain future events are addressed through risk identification, analysis, and response planning. And current problems or issues require immediate action and escalation and recovery. So understanding whether something's a risk, a constraint, or an issue it prevents us from wasting effort on analyzing certainties as probabilities, and it helps us focus our attention on uncertainty that matters to value delivery. The idea of understanding what we're dealing with helps us to address and get the importance, optimize our time, essentially, our effort in the right areas and the right processes. With PMBOK 8, they've introduced this concept of risk performance domain. As I mentioned earlier, we have the schedule domain, we have the scope domain, we have the governance domain. Now they've got risk as a performance domain, which before it was called a knowledge area. And they moved it. It's really not even a focus area. It's a performance domain now. It shifted it to that. And it's an important shift to think about it. When I first started getting involved with project management, risk wasn't even in the project management body of knowledge. They didn't add risk as a knowledge area until I think PMBOK 3, maybe 4. The risk or stakeholders got added. One of them got added before the other. I can't remember which, but it was not until the 90s, late 90s, that it got added in. And then it was treated as a knowledge area that was important and we need to think about it, but it really wasn't part of the project performance. Well, now they've moved it to an important performance domain that it's something that occurs throughout the project, like managing scope, managing schedule, managing cost. Now managing risk is something that goes throughout the schedule. And they've created, well, what they've done is they've combined the risk analysis. We used to have, I think it was 7 processes. There was the plan risk management, there was identify risk, and then there was quantitative analysis and qualitative analysis. They've combined those into this process called perform risk analysis. And then we had plan resources. And that's where our planning stops. And then the next 2, implement risk responses and monitor risk, are execution. Implement is an execution process. It's applied during the execution of the project. And then monitor risk is part of the monitoring, controlling, or the governance piece of the project. And I think there's a monitoring, controlling performance domain, and it falls in there. We won't talk about those today because they'll be covered in the next 6152 class in the spring. The risk performance domain emphasizes the project's team's ability to anticipate and prepare for and respond to and adapt to uncertainty and disruption of the project work throughout the project lifecycle. Rather than focusing on just predicting risk up front, this domain highlights the resilience that we can build into the risk resilience that we can build into the project, and the capacity to continue to deliver value even as conditions change throughout the project. In this case, risk management becomes an ongoing capability that's embedded in planning, decision-making, and execution, and closely aligned with other performance domains such as the scope, schedule, and finance domains. This domain, the risk domain, sets the foundation for understanding how traditional risk management practices that still matter, but how we apply them continuously and adaptively, not just during the planning process. However, our focus here in this course is on planning, but it's something that needs to be done throughout the project. It's planning activity that needs to be done through a continuous rolling wave planning process. It includes, includes the key processes. The plan risk management, that's the process where we establish risk-related activities will be conducted throughout the project. Identify risk is where we recognize the potential threats and opportunities in adapting as the project evolves throughout with new information. Perform risk analysis evaluates the risk through quantitative and quantitative methods to assess their impact and likelihood. And in plan risk responses is where we develop strategies to address identified risk, whether to mitigate threats or to exploit opportunities. And the implement risk responses is executing defined risk and mitigation in strategies. And monitor risk is where we continuously review for potential risk and we analyze the effectiveness of our implemented risk responses. This domain emphasizes work, the team's ability to work together, proactive risk management in alignment with other domains, project performance domains like scope, schedule, and finance. And effective practices in this domain involve embedding this adaptability and readiness into ability to manage uncertainties while we mitigate or minimize their negative impacts. And we also capitalize on developing in opportunities and acting on opportunities. That's this new performance domain. But in both PMBOK 7, 6, going forward into 8, we still have these processes here. And the first one is we plan risk management. This is effective performance begins by deliberately defining how risk management will be managed on the project. This plan risk management process enables how project risk will be approached, how it's going to be governed and integrated throughout the project. And we reframe risk as a performance domain, but we still have this practice of planning what we're going to be doing is setting the rules. It's still important for managing our engagement with this process of managing uncertainty. We're not trying to identify risk here. Instead, what we're trying to do is answer some foundational questions and things like how are risks going to be identified and analyzed and tracked? Who owns the decisions on escalation or owns the risk? How much risk is acceptable on this project? What opportunities are going to be, how we're going to handle opportunities alongside the threats that we identify. The inputs for this process provide the context, like the project charter sets expectations for our risk appetite. Our project management plan ensures integration and organizational assets promote consistency and compliance, and environmental enterprise aspects give us insight into like our risk appetite or tolerance for risk, items like that. The tools of this process, again, we have expert judgment here. They emphasize collaboration and alignment and not prescribed algorithms. Planning for risk is a leadership activity that requires a shared understanding amongst all the stakeholders. And the primary tool here, again, is meetings and conversations, applying those power skills of communication and influence and leadership. The primary output is the risk management plan. It defines the roles, the categories, the thresholds, the reporting formats, and the timing of our risk management throughout the project. This gives us the ability, it enables consistency and supports the broader domain, the risk performance domain, by ensuring that the team is prepared to anticipate and respond to and adapt to uncertainty as the project evolves. In short, the risk management plan transforms risk management from an ad hoc reaction to a deliberate and repeatable capability. This is the plan, the risk management process. And we're not actually planning our responses to the risk. This is where we decide how we're going to deal with uncertainty before it becomes an issue on the project or risk on the project. There's two key things to think about it, and they're really inputs to this process, and that's an understanding of our appetite and thresholds. The risk appetite sets the enterprise willingness to accept risk. Risk thresholds define the measurable limits that trigger actions. These are two important environmental enterprise factors that are closely related, but they operate on different levels. The risk appetite is our organization's overall willingness to accept uncertainty in the pursuit of its objectives. And it's a strategic item that is usually culturally driven, and it's often shaped by leadership priorities, the competitive environment, regulatory pressure, and organizational maturity. And it's really what are we willing to accept that moderate our schedule and help accelerate our time to market. If our organization is, say, a new entrepreneurial organization, we're going to be more willing to take risk in the marketplace, more willing to do more risky project management approaches. Where if we're in a large bureaucratic environment, like I used to work for AT&T years ago, and it was a huge bureaucracy, our project management approaches in what we did in the marketplace was very conservative. And our processes were very mature, sometimes constraining, but our appetite, the appetite for taking on risk was really low. Then we have thresholds. Thresholds translate our appetite into boundaries. It's the specific levels of exposure that we're willing to accept before we trigger some response, an escalation or a change in the approach. And they take this tolerance and make it actionable. When we cross a certain line, we're going to take some action. If a schedule variance, say, exceeds 10%, or the cost performance index drops below 90%, then we're going to escalate and implement corrective action. That basically sets up our triggers. In practice, projects don't event this appetite, we inherit it. Now, we can influence the appetite by the depth of the planning that we do and the level of uncertainty we understand about our project. But what we do is we take this appetite and we apply thresholds that are appropriate to the work, and we document this in our risk management plan. And because this risk appetite and threshold are typically defined outside the project, it's useful to classify them as impact coming from the project environment. And it's part of the project environment that we need to understand and operate. In treating the appetite and thresholds as environmental enterprise factors reinforces that they are governance driven, and we should align with organizational policy, stakeholder expectations, and external constraints. Doesn't mean that we take this as a one and done thing, because these appetites and thresholds can change over time as well as everything else. It's something we need to continuously be aware of as we're working our way through the project. Components of the risk management plan is the main output of this plan risk management process. And the risk management plan defines the project's risk approach, governance, and cadence. It's the primary output of the plan risk management process. Its purpose is to ensure the project team and stakeholders share a consistent and practical approach to handling uncertainty. The plan documents our approach to risk, the overall risk strategy, and the methodology the team's going to use to identify and analyze and respond to risk. We look at different categories, and we'll cover that in a minute, to ensure that risk identification is comprehensive rather than some ad hoc process we do. Second, the plan establishes governance. It clarifies roles and responsibilities, who owns risk decisions, how stakeholders' risk appetite and tolerances are going to shape those decisions. Risk thresholds identifies those, what levels of acceptable exposure we have, and how we're going to escalate. It talks about funding details of how risk will be supported financially, including guidance on contingency and management reserves that influence contingency management reserves influence our budgeting and finance domain. And third, the plan defines execution and control. The timing establish a cadence for risk activities, how often we're going to review risk, how often we're going to refresh our risk process. And it outlines the processes the team's going to use on how information will be documented and reported. And finally, the review and update frequency ensures that the plan stays current. We make sure that it doesn't get stale as the project environment evolves. And it's a plan here that turns risk management into a repeatable system that supports our risk performance domain by enabling the team to anticipate, respond, and adapt to risk throughout the project lifecycle. It's not just a static thing, but this plan sets the framework for that. And the identify risk is our next process in this domain. And identify risk is a continuous process of uncovering uncertainty that may affect project objectives, both threats and opportunities. The identify risk is the process of systematically and continuously recognizing uncertainty that may affect project objectives. And we're talking about here both threats that could cause harm and opportunities that could create value or improve processes. The key point is that a risk identification is not a one-time event. It's performed throughout the start of the project and performed at the start of the project and throughout the project. And our risk management plan will set that cadence up. And as the project evolves, assumptions change, constraints are going to shift, stakeholders introduce new perspectives, and external conditions change or fluctuate. And each of these changes can introduce new risk, or they can modify or impact existing ones. And there's a wide range of inputs here that reflect the idea that risk can originate anywhere through requirements, estimates, stakeholders, contracts, organizational environment. Many risks are readily visible if teams know where to look. If we can understand what all these documents are, they know where to go through their practice. The tools and techniques of this process emphasize collaboration, inquiry, and structured thinking, not prediction. Techniques like assumption and constraints analysis help surface hidden uncertainty. Facilitation and brainstorming encourage diverse viewpoints on risk. Modern project management explicitly recognizes the use of artificial intelligence to support risk identification and scanning of documents and patterns and historical data, but we don't eliminate the human aspect, and we need to keep the human in the loop on this. We don't use artificial intelligence to generate risk registers. They help us to analyze those risk registers. We can look for patterns and things like that, but we don't rely on it to produce a risk register. The primary outputs of this process, identify risk process, is the risk register. It captures the risks that we've identified, their attributes. There's also a register output called the risk report, which provides a higher level view of the overall exposure. It gives us, and we have updates to our assumptions here, lessons learned, to reinforce the idea that risk identification feeds directly into ongoing project learning and adaptation. In the context of the risk performance domain, identify risk supports resilience. In other words, robust resilience by ensuring that uncertainty is made visible as early as we can before it becomes unmanaged risk or escalates into a problem or some chaotic issue that we have to deal with. And the tools that we use, I'm not going to cover them all. There's a bunch of them. We'll talk about the key tools. And the effective risk identification relies on structured inquiry, collaboration, and analysis, not just prediction. The PMBOK lists many tools and techniques for identifying risk, but in practice, usually it's a small subset that does most of the work. And risk identification is fundamentally a thinking and conversation activity. It's not a mathematical one here. With mathematics, it's done in qualitative analysis. We have brainstorming and facilitated workshops. These are the most common techniques because they bring multiple perspectives together and help surface uncertainty early. Expert judgment complements this by adding experience level based insight, especially when projects involve unfamiliar technology or environments. Then we have assumptions and constraint analysis. This is particularly beneficial because it targets hidden uncertainty, areas where teams are operating on beliefs rather than facts. Interviews allow project teams to uncover risk that stakeholders may hesitate to raise during group settings. We have individual interviews. Checklists and prompt lists help us to ensure that coverage and consistency, especially in regulatory or repeatable environments, that back when we were looking at the Cynefin and the Stacey matrix, they had those where there's high levels of uncertainty and agreement, all of that. We're going to apply like known things. Well, checklists are really good to make sure we don't miss something. It's easy to take for granted something in those areas. Checklists are good there. Then we have SWOT analysis, strength, weakness, opportunities, and threats analysis. This helps us identify both threats and opportunities that enforce risk, that reinforce risk, that this reinforces that risks move in two directions. In other words, we've got strength and weaknesses that we have to deal with. Strengths would be, and then opportunities and threats. Strength and opportunities are generally associated with each other, and weaknesses and threats are generally associated with each other. And there's a whole structured analysis on that. We can apply that in planning as well. I think we've talked about it earlier. But finally, the PMBOK recognizes again that artificial intelligence is important here. And it's a key, this needs to support our judgment, not in replacing it. And the key takeaway here is that risk identification works best when it's intentional, it's collaborative, and it's revised regularly. And we don't rely just on prediction and automation alone. It's more about asking good questions at this point than it is forecasting. This is an example of a risk register. Again, the primary output of identify risk. The risk register captures unidentified certainty and serves as a foundation for all subsequent risk analysis and response planning. You can see it's got a risk number, a unique identifier number, who owns it, that's that escalation owner, the name and a description. Then we'll talk about the probability and the impact and the scoring and the mitigation and response summary and the status, what status it's in as we go through this. But the response summary is, if the risk occurs, how we're going to respond. This is that planning, this is a little mini planning activity for each risk. And what this gives you in the can response, when a risk happens, you can respond more appropriately. And a lot of times there's alternatives that get done here. And this becomes part of when you have a contingency that needs to be put in, it allows you to, sometimes these things can be approved, pre-approved, or they require minimal planning and it helps to prevent a risk when it occurs to becoming escalating into an issue, a problem that we need to deal with, one of those chaotic crisis type things. These things can be organized and adapted to your organization. I mentioned this last week, in my view, risk should be part of an initiating process. And PMI doesn't create it that way, but it should be right in there with stakeholder identification. It should be a risk identification, should be a initiating and planning activity. It should straddle both. But anyway, at the risk register here is the primary output and serves as a repository. It's not documentation for documentation's sake, but it's a tool that we can use for visibility and traceability of this uncertainty that we're dealing with. And at this stage, in the identification stage, we're really capturing risk clearly and consistently. And whether it represents an opportunity or threat, we want to understand what objectives it might affect at this point. And precision in terms of capturing the risk clearly and consistently is what's important here. We're not really too much concerned about the impact and probability. We're mostly concerned about capturing the risk at this point in the identification process. And as the project progresses, this risk register, we're going to continue to evolve it. Probability, impact, prioritization, and response information are all added through the qualitative and quantitative analysis process. The risk register becomes a living artifact. It's not just a static list. And ownership here is especially important. Assigning a risk owner ensures accountability for monitoring conditions, triggering responses, and escalating when thresholds are crossed. A key part of this state where we're at is identifying not only the risk, but who owns it, assigning an owner to it. And within the domain, the risk performance domain, the register supports in the process of enabling the team to anticipate change, coordinate responses, and adapt as new risks emerge. And a useful way of thinking about the risk register is that it's just not a list of things that might go wrong. It's a decision support tool for managing uncertainty and protecting the value that we're trying to deliver. This leads us into the next process in the domain, which is the perform risk analysis. Perform risk analysis evaluates the significance of identified risk to support prioritization, decision-making, and adaptive response planning. And sorry about that. Performing risk analysis, it's an iterative process that evaluates identified risks to determine their relative significance and influence on project objectives. It intentionally combines the qualitative and quantitative analysis I mentioned earlier. Instead of treating them as separate, they've combined them together here, and they're not considered isolated steps anymore. Qualitative risk analysis is throughout the project, and it focuses on assessing the probability of occurrence and the impact of individual identified risk. And additional characteristics may be considered like urgency, manageability, timing of impact, interdependency, common causes. The goal here is prioritization. We want to consider these other things, but we're not trying to precisely nail it down. We're just trying to figure out prioritization for the purposes of where we're going to focus our attention, right? If we've got a low priority risk, it may have a large impact if it happens, but it may be a low probability of occurrence. That makes it a lower priority. We might want to just monitor that, not spend a lot of time on it. But we have something that high probability of occurrence, we probably want to focus on that first. That's the idea of the qualitative part of it. The quantitative risk analysis, we might not require it for every project, but when we use it, it numerically evaluates the combined effect of risk and uncertainty on overall project objectives, such as schedule or cost. We usually employ things like simulations, sensitivity analysis, decision trees. These are the tools that help us quantify our exposure and do trade-off analysis decisions. And I mentioned that it might not be required on every project because this is requires special skills, usually requires a pretty deep knowledge of statistical analysis or these simulation techniques. They require expertise that we might not be able to afford within the project. It might be that the outcome is not technically qualifiable. Will you say technically, it doesn't meet a technical threshold. In other words, we don't have enough. Mostly what we're dealing with is process and not on generating out physical products. You see a quantitative risk analysis is really applied extensively where we have physical products that we're delivering because we need to be able to understand the attributes of those items because we can't, the rework is expensive. And again, it's really a factor of does the cost of reworking something benefit the negative impact of the cost benefit justify the cost of the qualitative analysis. It's the cost benefit in such a way. And this would be where you probably bring in experts to do this. But it's important here, though, we're not trying to predict the future, but we're trying to create insight into our limited attention and our limited resources are focused on the risks that matter the most. The outputs of this process are the updating the project register with refined information that feeds into the risk report, which provides a aggregated view of the project's risk exposure. And within this risk performance domain, the perform risk analysis enables us to adapt our plans and refine responses and strengthen our resilience as conditions evolve. It's about deciding where to look and when to act, not about eliminating uncertainty. And no point where we've ever talked about eliminating uncertainty completely. We've talked about defining uncertainty, which reduces the overall magnitude of uncertainty that we're looking at. The risk categorization, this is where we want to categorize the risk. And I mentioned this earlier in one of the earlier courses, but it's the known and unknown risk. It helps us, risk categorization helps teams manage different types of uncertainty appropriately. And it helps project teams distinguish between what we know we don't know, and what they know and what they don't know, and what they can foresee. It helps teams understand that. You can look at this and trace the similarity back to the Cynefin and Stacey models. This is an extension of those models here to classify risk. Previously, we were looking at how to react to why this thing is difficult to what we know and what we don't know about it. It's a critical distinction here because different types of uncertainty require different management approaches, as we've already seen. Known unknowns represent facts, requirements, and confirmed conditions. These aren't risks. They should be managed through scope and planning and executing controls. Again, apply the known techniques. Then we've got known unknowns. This is where the classic project risks fall into. We're aware of the uncertainty, and we can, within certain parameters, estimate the probability of its occurrence and the impact of it occurring. And usually they're well suited for further analysis using quantitative or qualitative methods, and they're well suited for traditional response planning. We can accept the risk, we can transfer the risk. I'll talk about that in a minute. We can develop mitigation plans for. Then there's the unknown knowns. These are hidden risk that the knowledge exists somewhere within the organization or industry or past project, but it's just not surfaced. This is where expert judgment, lessons learned, retrospectives, interviews, and document analysis. This is where AI can really help through document analysis to convert these into known risk. We want to move these up to the unknowns. Really, if you can think about it, we want to try to move everything up to the point where we can manage it through planning, essentially. Then we have unknown unknowns. These are emergent risk, and we can't identify or analyze these in advance. They're addressed not through prediction, although we can't predict these, but through the resilience and adaptability and contingency reserves and flexible governance that aligns with our risk performance domain. We can generate management reserves. We can deal with these things. This is more the crisis, put out the fire things that happens on a project. And usually the defined response to an unknown is a workaround. And a workaround is a type of contingency approach where you have to work around that problem and solve it and then figure out how to manage it later on. Understanding all these categories helps to prevent us from overanalyzing things that are certain, prevents us from ignoring hidden risk or falsely assuming uncertainty that can be predicted. This helps focus us on what we're doing. And the whole idea is we want to become more efficient with our time and resources that we have. It's not about knowing everything, but it's about knowing what can and can't be known and what we can and can't address in the risk management process. The quantitative and qualitative risk analysis, this is the risk analysis process. The analyze risk, I think it's what it's called. The qualitative analysis prioritizes individual risks, while quantitative analysis estimates overall exposure. And we can use each of these whenever the decision warrants it. And that goes back to the quantitative approach may be optional based on the nature of the project. The qualitative and quantitative risk analysis serve two different purposes. Projects don't automatically need both of them in the same depth. Qualitative risk analysis is the default approach, and we use it throughout the project. And here we prioritize risk by addressing the probability impact. We can also supplement these, as I've talked about before, by factors such as urgency, manageability, and proximity. The goal is to create a ranked view so the team can focus its efforts where it matters the most. The initial stakeholder register that we have just identified it. Now what we're trying to do is rank it and ranking them into which ones we should address first. And ranking is a little different than priority. And priority depends a little more on further analysis, but we want to rank these so we can focus on those. Qualitative is especially valued when data is limited and when we have time constraints or when we need some triage. When there's more information, the triage implies. Quantitative risk analysis goes further by numerically evaluating the combined effect of risk uncertainty on objectives. And most commonly, we look at things that impact our schedule or cost. And it's useful when decisions require this greater level of decision, like when we have major funding decisions or we've got contractual commitments or regulatory constraints, or there's really high consequence outcomes. Like I mentioned before, the cost of the rework justifies the expense. In other words, it's cheaper to do the analysis to prevent rework. And sometimes maybe the rework is minimal, or the anticipation of it is minimal that we don't do. We'll just accept it. That's a perfectly viable way of doing it. We use techniques such as simulations and sensitivity analysis to better understand these trade-offs to inform how much reserves we need to keep. A practical rule is that we want to use qualitative to decide what to pay attention to. We want to use quantitative analysis to decide how much exposure we have and what we should set aside or commit to. In the mindset of the performance domain, both of these forms of analysis support our risk approach, the resilience of our risk approach. The qualitative supports fast decision making and prioritization, while the quantitative supports stronger governance and informed commitments when stakes demand it. A big part of this qualitative analysis is the probability and impact assessment. The probability impact assessment translates uncertainty into priority by evaluating how likely risk is, and how much it matters. Probability and impact assessment is the backbone of qualitative risk analysis. The goal is not precise prediction, but consistent prioritization. The team focuses its effort where it has the greatest effect. Probability is the reflection of the likelihood of something occurring. It reflects the likelihood of occurrence. It's informed by historical data when available, in expert judgment and the assumptions that the team is operating on. The probability reflects the likelihood of occurrence, and it is informed by historical data when it's available, expert judgment, and the assumptions the team is operating under. The impact evaluates what happens if the risk occurs. It should be assessed against the project objectives, such as schedule, cost, scope, quality, performance, and value delivery. Because a high impact risk in one project may be moderate in another, depending on constraints and stakeholder priorities. The risk priority results from combining the probability and impact using the project's agreed scoring approach and thresholds. And those thresholds should align with the risk appetite and be defined in the risk management plan, which we should define at this. Finally, here we're trying to emphasize that effective qualitative assessment goes beyond probability and impact. Teams need to consider urgency, proximity, how soon it should occur, detectability, how early can we see the risk, how interdependency, how it interacts with other risk. And these effects are important when complex projects have ripple effects in your project. And this is an example of a scale, probability impact definitions. Defining probability and impact scales is an example here. And the probability and impact scales translate judgment into consistent and repeatable risk prioritization. The table here provides an example of how probability and impact scales can be defined on a project. The point is that it's not the specific percentages or dollar amounts or durations that are shown on here, but it's the structure and intent of the scales. These scales can vary between organizations, but so like the scale here, very high. They've created these different, sometimes some places use t-shirt sizes like medium, small, that thing. Here they got high, low, medium. In the probability, they just assigned that a very high one has a 70% or greater probability of occurring. High is 51 to 70%. And they also include the impact on time. They're saying it's 70% occurring within the next 6 months. And it has over $5 million. And this is the impact on this particular quality. The impact could be on it could be on time. It could be on scope. It could be on another or value delivery itself. And this is just documenting this. And this creates a common understanding and a framework for understanding how they're going to go. The probability is expressed in ranges and reinforcing that qualitative risk relies on informed judgment rather than on precise prediction. The impact is defined relative to the project objectives. making the assessment meaningful and actionable. And notice here that the thresholds are context dependent, like a 1 week delay or $100,000 cost overrun may be insignificant on one project and critical on another. And this is why probability impact definitions must be tailored to the project in line with stakeholder risk appetite in responses and documented in the risk management plan. This example includes positive and negative impacts and reinforcing opportunities and threats. The purpose here is consistency. When we use shared definitions, risk prioritization becomes transparent, it becomes repeatable and defensible. It supports better decision making within the performance domain. And the numbers don't make the decision here. The shared definitions is what we rely on for the decisions. This is another way, probability impact matrix. This one here prioritizes both threats and opportunities using a consistent scoring approach. And this probability impact matrix provides this. You'll see this you should see this in your PMBOK reading. This is almost exactly what they have in the book. But it provides an example, a more detailed example of how risk can be prioritized using a scoring mean. We've got the categorization and the impact listed in range, and now we're going to cite a scoring which helps us to rank these things. On the left side, the matrix evaluates threats, combining probability with negative impact to identify that risks that require mitigation, transfer, or avoidance. Here they've got they're high, low. We need to translate these probability categorizations into what we set up in the scale earlier. These two charts are independent in this context, but they're related in that we need to transfer one to the other. And on the left side, we're talking about opportunities in the same way, combining probability with positive impact. The scores here are not meant to be precise forecasts, but they provide a consistent way to compute risk so that attention can be focused on what matters most. Different organizations and different projects may use different scales, weights, or color thresholds depending on the risk appetite and the governance that we have. What matters most here is not exact numbers, but the team uses a shared, transparent scoring approach that's aligned with the risk management plan. This consistency enables better decision making and supports the risk performance domain by ensuring the risks are prioritized deliberately than intuitively. And this is how this might look. Risk analysis, this is updating the risk register. After we've done analysis, we need to go back and update the risk register. And the results are used to prioritize risk and update the risk register for action. Once we've done the qualitative and quantitative risk analysis, the results are captured in the risk register, and it creates a value and it informs the prioritization. And you can see how they've done and taken the risk register, and they've got the likelihood, they've anticipated likelihood it's going to occur is high, the impact is high, and they've got this score here of 72, and they've given this a risk rating of high, and they've got their response that they planned out here, and they've got the owner over here. And you can see how they've used the scoring to do this and how it gives you a consistent way of looking at this. The higher scores indicate that the risks require more immediate attention and escalation and funding, where the lower scores may be accepted, monitored, or handled through some other standard controls. And updating the risk register ensures that this information remains current and that it's actionable and it's aligned with proper decision making. The risk register is a living project management tool that supports response planning, ownership assignment, and ongoing execution of management of risk through execution. It's updated continuously and as our understanding of risk evolves. This side talks about quantitative risk analysis, how we can display those. It uses numerical methods to estimate the combined effect, which I've talked about before. It focuses on understanding of this combined effect of uncertainty on overall project. At this stage, the goal is insight. Quantitative analysis provides answers such as what is the probability we'll finish by a certain date, how much contingency that we'll need to achieve the acceptable risk level, which uncertainties drive the greatest variability. And some common techniques are Monte Carlo simulation, which is probability analysis, decision tree analysis, which applies probability to decisions. Sensitivity analysis is how sensitive are things to change, and it produces something called a tornado diagram that we can do. And these methods help us to model risk scenarios and generate a range of outcomes rather than a single point estimate. And that's why the results are expressed at its confidence level, like in P50, in P80, I think. Do we have that on they didn't put the P's on this. See if they're on here. Yeah, they're not on here, but sometimes you can put those on your risk register. It's why the results are expressed in confidence levels in P50 instead of fixed numbers. It's a visual distribution here. We've got it on the probabilities. These are probability numbers. What you can do, you can apply what's called moment point analysis and things like that, statistical tools to figure this out. But again, it requires a high level of expertise. Most projects don't fail because of a single risk event. They usually are shaped by the interaction of lots of small uncertainties, which creates a variability. Quantitative risk analysis tries to make these small things visible. We can judge the impact of a number of small variances over the project itself. And it's not all, like I mentioned, it's not always required. It's good for large projects. It's for high uncertainty. The output here is to support risk-informed decision-making. And we can update the risk register, and the outputs of this process are updating the risk register. Again, we have another example here, just showing this on the screen. And then we have the risk report. The perform risk analysis is valuable because it transforms the list of identified risk into prioritized actionable information. The first major output is the updated risk register from this process. And they're not just descriptions anymore. They have relative priority, and we've captured the probability, we've captured the impact, and we've often applied a risk score or exposure rating that the risk can be compared consistently. And we've clarified ownership, we've set up triggers, we've analyzed status, we've looked at assumptions, and we can monitor this risk over time. And the second output of this analyzed risk process is the risk report, which is designed it's really updating the risk report, which is designed for communication in governments. And the risk register's detailed and operational report summarizes the overall exposure and what the biggest risks are, what the opportunities are, whether we have trends up or down. This would be the report that you would report out to stakeholders. If quantitative risk is performed, it's going to include our confidence ranges and our aggregate exposure for risk and schedule costs. Finally, risk analysis produces project document updates. We're going to go back and update all these. We may have to adapt our plans. We have to adapt our scope, our thresholds, our assumptions and constraints are refined. Some risk will convert into issues because they need to be reflected in the issues log. Lessons learned will be captured to improve future identification analysis. And in this mindset, the outputs matter because they make uncertainty visible, support timely decisions, and ensure that risk management is integrated with planning and execution and not separated from it. The plan risk responses is the final part of the planning of the risk performance domain. And plan risk responses defines how the project will address prioritized threats and opportunities and protect enhanced value. Now we've got a risk register with all this stuff in here. What are we going to focus on? We want to take from the risk register and start planning a response for the highest risk, whether they're opportunities or threats. And the plan responses is where we move from analysis to action. And up to this point, we've identified risks, we've analyzed their probability, their impact, and their overall exposure. And now we're going to decide on what we're actually going to do about these risks. And the objective here is to develop an appropriate, feasible, and agreed upon response strategy for both our threats and opportunities. And we want to emphasize here that responses should be proportional to the risk exposure and aligned with organizational risk appetite and threshold. For threats, some common strategies are to avoid. And that means that we're going to change the plan to eliminate the risk entirely. Maybe we can change the plan by just not, the classic example of this is just reducing scope. Mitigate is we want to reduce the probability or impact. And this is where we want to create some mitigation plan. And then transfer is by shifting ownership through contracts or through insurance. And then we can just simply accept this, which is when the cost of action outweighs the benefit of this. And for opportunities, the goal here is not to avoid it, but it's to capitalize on it. And strategies for uncertainty are to exploit the uncertainty, to ensure that it occurs, to enhance it, to increase the probability of impact that it's going to occur, to share it by partnering with others. Maybe we want to, it's a new process that we can share with others, and we can adapt accept it when the action is not justified. When proactive, we can just say, hey, this is something if it happens. And my experience, I have a good, interesting experience with this. I worked for a project at USAA a long time ago, and occasionally did hackathons where they could work on something, anything, the teams could work on anything they want as long as it was within the definition of what they were, the goal, the value they were delivering. And they came up with a whole new process of analyzing video images, portraits that people submit to their profile. And at the time, it was like new technology. This would have been about probably 15 years ago now. And we use AI to analyze video and portraits and images and things like that, more advanced. But they were able to patent that process and license it out. In that way, they exploited it and enhanced it and then shared it and it created a whole new stream of revenue for them out of that process. That's the thing sometimes that can happen. But the team may want to, in addition to these strategies, the team may want to set up a contingency response. And these are actions that are executed only if the triggers occur. And that's where the risk response comes in. This helps avoid over-planning while maintaining readiness. The plan risk relies heavily on expert judgment, facilitation, and decision-making techniques, such as cost-benefit analysis. The outputs of this process are visible throughout the project, across the project, really. The risk register and risk report are updated and are used as inputs to many other processes. They may help generate change requests that affect the schedule, the cost baseline, and this becomes inputs to a lot of things. And then it reinforces an important point that risk management is integrated with planning and governance. It's not a standalone activity. The risk responses ultimately are designed to protect project objectives from downside risk while positioning the project to capture upside value in supporting informed decision-making throughout project execution. This is the mitigation planning and contingency reserves. Mitigation planning reduces the exposure while expected monetary value helps size contingency reserves. Mitigation planning focuses on only actively reducing risk exposure rather than waiting for a threat. The response in your risk register might be a mitigation strategy. And you mitigate it, really the idea is to mitigate it to a point where we can accept the resulting, what's called residual risk. If we have something that's maybe say a 70% of occurrence, which is a high percent of occurrence, we want to move that down to where it's maybe at 20% of the impacted occurrence, or the probability of occurrence is 20%. Get it down to that acceptable level. But they're proactive and they're implemented as part of our normal project execution. For example, here, if we have early prototyping, can reduce the probability of rework late in the project, while building a schedule buffers may reduce the impact of unavoidable delays. The key idea that we don't eliminate the risk entirely. It just shrinks the risk profile. Even with mitigation, we have residual risk that remains, and that's where contingency reserves come in. And we recognize the concept in risk management of expected monetary value. It's a common technique for estimating the contingency reserves, and it combines the probability that a risk is going to occur with the financial impact. And we can calculate expected monetary value across multiple risks, and we can estimate a reasonable contingency reserve that reflects that exposure rather than guesswork. What we can do is we can mitigate it down and say we have a 20% probability that a $1,000 impact will occur. Well, then the expected monetary value of that risk event is now $200. We apply $200 as contingency reserve for that activity or that task, and then we aggregate we do that for every activity, and we aggregate that up and we come up with our dollar amount of the contingency reserve for the project, like we looked like in the budgeting last time. And that's how we calculate that. We calculate that for each individual risk. And project management tools can do this for us. And we can facilitate automation of this basically by just coming up with the numbers, going through the quantitative and qualitative process and coming up with these. But by calculating this across all these risks, we can estimate a reasonable contingency reserve that really expresses our exposure rather than some guesswork. And it's important to here to continue to distinguish contingency reserve from management reserves, like I did last week, that contingency reserves are planned, visible, and tied to identified risk and part of our cost baseline, where management reserves are there to address the unknown unknowns. And they're controlled generally outside the project baseline. And their linkage between mitigation planning and expected monetary value reinforces that the principle that governance and planning needs to be not just analytical, but needs to inform our process. Effective projects don't aim just to eliminate uncertainty, they plan for it intentionally. And we plan for it through contingency reserves. Expected monetary value, this is an example of how we calculate it and how it's used. Expected monetary value translates exposure into financial insight and informs contingency planning. And it's a quantitative technique used to estimate the exposure with associated individual risk. And it's not to predict exact cost, but to express uncertainty in terms that the project leaders can make informed decisions about reserves, trade-offs, and risk responsibilities. We calculate expected monetary value for individual risk. By doing this, we can gain visibility into which risks contribute to the most overall exposure. And once we've calculated this, we can capture this on the risk register, and we can sort the risk by expected monetary value. That attention and resources, again, can be on the highest contributors of potential loss. So it's another way of refining our priority of what we focus on. And we can, when expected monetary value when expected monetary value, I want to say earned value, but it's not. Expected monetary value, risk are aggregated. They provide a rational basis for determining contingency reserves. And you can see on the screen here, they've got this risk, we've got this project delay. Probability is 30% that it's going to happen. And that we've determined that that's a $200,000 impact. And we take that 30% probability times the $200,000 overall impact, and we've come up with an expected monetary value of $60,000. And we can take all individual contingency amounts, the expected monetary value, and add them up. We've got A, 25K, this project B, 60K, another 60K. We add all that, and then we come up with a total contingency reserve of $145,000. That's how much we need to, in our funding reconciliation, we need to account for. And it can tell us here, the updated risk register can tell us exactly which one of these are. And then we can take these and apply these to our individual activities in the schedule. And that we can integrate that into our funding reserves. We know that, okay, our budget baseline is, say, $100,000, but we need to put let's say $1 million. And then we need $140,000 in contingency reserves. Our overall performance management budget is going to be $1,145,000. That's how this calculation works. The outputs of this process is that the planned risk responses are documented and funded in the outputs and integrated in the overall project plan for execution. And the plan response processes that embed risk decisions on how the project will actually be executed and governed. And the outputs ensure that the risk management moves beyond analysis and becomes part of our day-to-day project work. That's the key emphasis here. The first major output is the updated risk register. For each prioritized risk, the selected response strategy is documented, where that strategy is mitigation, avoidance, transfer, acceptance, exploitation, enhancement, or sharing. Risk owners are confirmed, triggers are defined, and the residual or secondary risk are identified in the risk register. The risk report is also updated to reflect the response decisions at the aggregate level. This includes changes to overall risk exposure, key response themes, any kind of items requiring leadership, risk items requiring leadership or escalation. The the risk report supports governance by communicating how the project intends to manage its uncertainties. And many risk responses require changes to the project management plan. We have the change requests that need to be generated and change the plan that affects scope, schedule, cost, procurement, sourcing, ensuring that approved responses are formally incorporated into the plan. Risk responses may also lead to updates in the baselines and subsidiary plans. We may need to adjust our baselines, such as the schedule and cost baseline or our resource management plan. And mitigation actions might add task or cost. And while transfer strategies may introduce constraints such that are in contracts or insurance. And risk response planning can result in funding decisions, including an allocation or refinement of contingency reserves and tied to unknown risk. And this reinforces the link between risk management and financial planning. And all this taken together ensure that the risk responses are authorized, we have proper resources to them, proper planning applied to them, and that the plan is executable, which supports the domain's emphasis on integration and value delivery. To conclude, effective risk management emerges from understanding uncertainty, complexity, and context, and responding intentionally. We brought together uncertainty and complexity and risk management into a single integrated view of project decision making. We began by recognizing that uncertainty is inherent in projects and that risk is how uncertainty becomes measurable and manageable. And as complexity increases through interdependency, change, and human factors, the ability to predict outcomes decreases, requiring more adaptive approaches. And that frameworks such as the Cynefin and Stacey matrix help us diagnose context and choose decision strategies that fit our situation rather than applying a one-size-fits-all method. And from there, we shifted into project risk management, emphasizing that effective risk management depends on deliberate planning, continuous identification, meaningful analysis, and intentional response selection. And that tools such as probability impact assessment, qualitative and quantitative analysis, and expected monetary value prioritization and informed financial decisions. And then finally, we reinforce that risk responses only create value when they are documented, funded, and integrated into the project management plan. And that risk is a performance capability that strengthens resilience and supports value delivery in uncertain and complex environment. Projects don't succeed by eliminating uncertainty. They succeed by managing uncertainty well. That is a long lecture. Hopefully you guys are still with me. Do you have any questions on any of this? I know I just spoke right through it. No questions?
No.
Okay. You guys have a great day and a great week. Next week, we will meet in Frisco for those of you that are on the 6151.21 and we will talk about, it'll be short. I don't think we'll be there too long, but we'll talk about probably less time than today. But we'll talk about AI. We haven't really talked about stakeholder engagement. We talked about stakeholder engagement a little bit, but we'll talk about that a little bit. And then we'll talk about the presentation. And we'll go through all the competencies and talk about some key takeaways for those. And we may do that as a group activity. We'll see. I'd like to break it up and give you guys a chance to use the Infinity AI tool that we have. Okay. Thank you and have a good day.